Good morning, students. So last we are discussing about metallurgy chapter. In that two processes already we are completed. Now we are going to discuss about the third process. So what is the third process? Already last class to example we discussed. So once again I am explaining. So third is the refining of metal. So in refining of metal, what are the processes are there? So that is shortcut, delay, pole beku, ELMO, macro zone. So these 10 points we are going to discuss about this refining of metal. Distillation is over. Next liquefaction process is over. So where distillation is observed, boiling point is less. So either metal or impurity also you can consider. Next, liquefaction. Liquefaction means which has a low melting point. So that we are separated. So now third one we are discussing about a polling process. So polling process. So that pole. This pole we are taken freshly cutted bamboo stick. See this stick. So that bamboo is what? Organic. Organic means what? It is made up of with carbon and hydrogen. So carbon and hydrogen are what? Powerful reducing agents. So in this process what happens? You take impure metal, molten state. Impure metal, molten state. So molten state means what? Highest temperature. So the temperature is very high. And this mixer is stirring continuously with the bamboo sticks. So this mixer is continuously stirring with bamboo sticks. At this temperature, all the particles are present in the bamboo are dissociated. You are getting what? Carbon and hydrogen gas. So that reduces the impurities. So in that, suppose generally this process is using for a purification of copper. Suppose copper sulfide is there. So copper sulfide impurity is there means it is converted into, in the presence of oxygen, it becomes as copper oxide. Next, this copper oxide treated with the carbon, you are getting the copper plus carbon monoxide. Otherwise, hydrogen. So you are getting the copper plus H2O. So you are getting pure metal. So it is olden days, the purification of copper, they are using this one. So polling process. Next, besimerization. So besimerization and cupellation both are same. See, besimerization and cupellation. So these are blowing of air. So blowing of air on that mixer. See, first you discuss cupellation. So cupellation. See, generally it is observed in your that goldsmith. So they are purifying the silver in the process. They are taken a small crucible. So in the small crucible they are taken what? That silver. So silver is always impurity with lead. So impurity with lead. So now this crucible they are heating. So highest temperature they are heating and continuously blowing the air on the surface. So they are sending air on the surface. Then what happens? The lead impurity going outside as a vapors. So the silver will be purified. So this process is what? Blowing of air on the surface of molten state of that one. Next, fifth one, besimerization. So Besimerization, it is same process, the same process of accumulation, but these are separated in large quantity. Large quantity, it is the industry process. The same process you are observing in the small quantity in home. So, but besimerization is a large quantity, but the molten state of impurity is continuously flowing with air in large quantity. That is the besimerization. Next, electrolysis. So, sixth one, electrolysis process. See, already we discussed which one you are preparing the electrolysis process means the first group, alkali metal, alkaline earth metals and aluminum. Generally in reduction process also they are using. Next here, any metal. In what way they are taking means you are taken as a impure metal. Impure metal you are taken as anode. This is taken as anode. Next, so a thin wire. So that is a pure metal. Taken as cathode. Here. So we are taken, it is a electrolysis process. The impure metal they are taken as an anode. So here, electrolytic solution. Suppose you take gold. So the gold rod, big rod you are taken as an anode. Next, gold wire, pure. It is. So now it is electrolytic solution. You take AuCl3, molten. So molten AuCl3, gold chloride we are taken and we are sending the current. So then what happens here? From this, the gold is coming outside. So it is continuously corroded. Corroded means the concentration of the rod is continuously dissolving in this. So the gold is coming outside, Au plus 3. Now this Au plus 3, it is coated on the surface of this. So after some time you see this rod become as a wire, this wire become as a rod. So completely purified. So here whatever the unwanted impurity, so that is coming down. So as some impurities, all impurities are coming down. So that impurities you are called as anodic mud. So this contains noble metals. So that means platinum. So silver, gold, so that means the anodic mud contains noble metals are present. So any metal you can also utilize in this electrolysis process. In this you are getting 99.99% of purity of metal is available. So here the important which is anode, which is cathode, what is the present in anodic mud. So they will ask the questions. Next, so Mond's process. See, in this process we are purifying the nickel. See, nickel is combining with the impurity form. So now this is heated with carbon monoxide. So we are heated with the carbon monoxide. See, the nickel is D block element. Next, carbon monoxide is a strong field ligand. So this is powerful ligand, D block element. Directly you are getting the nickel carbonyl, tetracarbonyl nickel. So this is become as a vapors. Next, impurity is unreactive. So impurity is available as a solid form. So this means the vapors are coming outside, we are condensing. So condensation, by using the condensation, we can separate. So you are getting nickel carbonyl compound. So now this is heated. So nickel is separated. So you are getting pure nickel. Next carbon monoxide is going outside. So you are getting pure nickel. So carbon monoxide eliminated. So this is mods. Next, eighth one, Van Arkel's process. In this, so which elements are purified? So here, every D black element, second element, scative chroma, so titanium. Next, second group, Ezran motet, zirconium. Next, last weight, hafnium. So that type of metals are purified. So here, what we are taking, titanium. Suppose a titanium plus impurities. These are heated with iodine. So then these are TiI4. So vapors. Coming impurities are in the form of solid. So you use condensation. So both are separated. So you are getting a titanium I4. Next you heat this one. So titanium you will get a pure. Next iodine coming outside. Next. So titanium, zirconium, hafnium we are using here in this. Next. So ninth, you can take zone refining. So zone refining process. So in this, we are using the semiconductors. So purification of the semiconductors. So silicon and germanium, we are purified. So in this process, what we are taken, so silicon and impurities, silicon and impurity of crude metal. So we are taken, these are converted into thin sheets. So the silver impurity material, they are converted into thin sheets. And the thin sheets are continuously rolled with two hot rollers. So above and below. So two hot rollers are running. So two hot rollers. So in the middle of two hot rollers, these thin sheets we are sending. So in the Xerox shop, you are seeing that lamination. So in between two hot rollers, the paper is laminated in the same manner. So then what happens if you are sending means, this is continuously, so many times, above one roller, below one roller, continuously moving. So then what happens? So previous, every one is in different order. Suppose this is, you take as silicon. Next, that impurities. So impurities are present all over the sheet. So number of times the roller is passing. Number of times the rollers are running. So finally what way is observed? Suppose impurity has low melting point, that is dissolved. Next, otherwise silicon and germanium are less melting point, these are dissolved. Suppose the roller is continuously moving, so what happens? Impurity is dissolved. So along with the roller, the impurities become as liquid and moving that side. So after many times if you see, then what happens? All the silicons are observed left side. Next, who are readily soluble with the heat? So that is dissolving and moving along with the roller. So you are getting impurity. So this becomes as silicon zone. This is an impurity zone. So next you cut these two. You cut these two means perfect pure silicon is available. So this is zone refining. So who are purified? That is semiconductor. Silicon is germanium. Next, last one, the chromatography. See, we have so many processes to purify our separation. If any process is not suitable, then one and only option, that is chromatography. So it is a wonderful technique. So chromatography. See, chrome means color, graphene means separation. So olden days, based upon the colors, the compounds are separated. So nowadays, the wonderful techniques are came. The chromatography contains two important points. So what are that? One is stationary phase. So stationary phase and mobile phase. So the stationary phase is observed as solid and liquid. So mobile phase is observed as liquid and gas. So on the stationary phase we are running mobile phase. See, so solid stationary phase. So actually here you can separate. This is one step. You take stationary phase. So stationary phase contains two members. One is a solid, another one is a liquid. Next, on this solid, mobile phase is running. Mobile phase. So here liquid and gas. Next, on the liquid surface also, mobile phase is running. So here also, the mobile phase is observed as liquid and gas. So here, the examples are important. In what way? So stationary phase is a solid, mobile phase is a liquid. So the best examples are, see, column chromatography. So column chromatography we are using. Next, that famous column chromatography. Next, solid. Solid is the stationary phase, gas is the mobile phase. So the example is, so gas chromatography. Next, so stationary phase is liquid, mobile phase is also liquid. So the example is paper chromatography. So PC. So paper chromatography we are using. Next here, so HPLC also famous. So high performance liquid chromatography is also example of stationary phase and mobile phase. Next here, liquid is the stationary phase, gas is the mobile phase. The example is GLC. So gas liquid chromatography. So what is the main technique in the chromatography? See, suppose you are taken impurity. See, suppose A plus B plus C compounds are there. So A is a pure. So B and C are impurities, are present. So first of all, we are taken stationary phase. So we are taken stationary phase and it is mixed with some suitable solvent. So on the solvent, these three are dissolved. Next, this is, we are taken as one spot. So on the surface of a stationary phase, this mixer we are taken as a spot. Next, this total. So it is what happens, it is adsorbed. So which type of adsorption? This is physical adsorption phenomena. So here in this chromatography, which effect is observed? That is a physical adsorption. This is also important. Now this is taken into mobile phase. So now it is immersed in mobile phase. So the liquid, any one of the liquid according to separation capacity. So if you take any immerse, then what happens? From the dot, see, slowly the liquid is coming up the stationary phase. In the meanwhile, it is touches this one, and every one is separated. In what way you are getting lost? So this is dotted line here, A, B, C. So depending upon that, whatever A, C, B, so like that they will come. So if A has a strong adsorption, so it is slowly moving. So that polar nature, if you take the polar nature, is in the which form? A is greater than, C greater than B. So here stationary phase has a polar nature. So upon the polar, A also polar nature, so strong attraction. So that's why it is not moving. Next, second one is C, slowly moving. So it is what polar point is very less. So means that is a fastly moving. Say after the drying, you can cut this one paper. You are cutting up to this one means A is separated. You cut here and you remove this one. And A and C and B compounds are perfectly separated. So whatever the process, you are not going to separate any compound. The one and only wonderful technique is chromatography that contains stationary phase and mobile phase. So who are stationary phase? What are examples? That is also one important point.